Today's video is going to be about our lesson on maximums and minimums. So we've talked about maximum means how tall our parabola has hit, so it would have a concave down type of look. So a maximum would be right here at the top, as tall as my graph could be, or sorry, my parabola, and a minimum would be its lowest point. So what we're going to be looking at today is more about max and mins. So our first one says consider the function f of x equals parentheses y minus 6 squared. So like many functions, this function takes any input and the resulting or the output numbers are going to be super big or super small. What do you think the smallest output would be for this, and which input gets the smallest output? Well, let's see. We got a table here that has some values, so what we're going to do here is we're going to take these values of x and plug them in. So for my first one, I have f of 4 equals 4 minus 6 squared. Well, I know that I need to do everything in the parentheses first, so 4 minus 6 is actually going to give me a negative 2. And if I square that, meaning I'm going to take negative 2 and multiply it by negative 2, two negatives equal positive. So if I have a 4 here, my output is going to be 4. So remember, this is input and this is output. So it kind of stayed the same. Let's try 5. So if I have, 5 minus 6, so 5 minus 6 squared, that means 5 minus 6 is a negative 1. And if I square that, negative 1 times negative 1 is actually going to give me a positive 1. So there's my answer there. And let's try 6. If I plug in 6 minus 6 squared, 6 minus 6 is 0. Anything to the power of, so 0 times 0, anything times 0 is just 0. So I start seeing that my numbers are kind of getting a little bit smaller. So let's see 7. If I have 7 minus 6, so 7 minus 6 squared, well 7 minus 6 is 1. 1 squared is actually going to give me also 1. And if I plug in 8 now, 8 minus 6, parentheses first, inside, which should be 2. 2 times 2, or 2 squared, is 4. So I can see that we're starting to have a pattern here. So 9 minus 6 is going to give me what? 3. So now I have 3 squared. 3 times 3 is 9. So if I actually graphed this, and I'll show you what it actually looks like, when I graphed all the points, I can see that there is a parabola that's forming. So the question is actually asking, which is the smallest output, or what is the smallest output possible? And I can see here on my table, the smallest output that I can have is a 0 with an input of 6. So which input gets us the smallest output? Well, the input that gives us the smallest output is 6, and the smallest output is 0. So we can say the smallest output is 0, and the smallest input or sorry, not the smallest input. The input that gives us the smallest value is 6. Alright, so we can always create a table, especially when we have a function. We can definitely create the table to help see where our smallest output will be, and what our biggest output will be, and so on and so forth. So now I want you to open up Desmos.com, and we're going to plug in the equation. So now we're going to plug in the equation from here, f of x, parentheses, x minus 6, into our Desmos. So now that I've graphed it and showed you, now we're going to have our equation. F of x, or you can type y, equals x minus 6, to the power of 2. And in order to get that power of 2, what you can do is hit Shift 6 in order to get that. So as we can see, our parabola, what the question is asking, is our parabola concave up or down? Well, it's concaving up because our parabola is facing up, meaning it's probably going to have a minimum because it's this minimum point that I can see on my graph. Okay, so now what we're going to do is we're going to try a different one. Now we're going to consider the function with a negative sign in front of the parentheses. So same equation, just a little bit different, has a negative sign in front of the parentheses. And we're going to see what are the coordinates, so what are the x and y points, so coordinates meaning x comma y, of this vertex. Is our vertex a minimum or maximum? So let's test it out. If I put a negative in front of this, it's actually going to concave down. It's going to have a sad face, and it's actually going to have a maximum, because now I have the maximum or the highest point on my parabola. And let's see what the coordinate is. If we get as close as we can, the highest point is going to be 6, 0, similar to what the last one was. They're actually exactly the same, just it flipped upside down. How cool is that? So then we have for each of these following functions. So for this part of our lesson, we're actually going to fill in our table first, graph it ourselves, and then we're going to compare it to Desmos and see how accurate our equation is. So we have our first one here. We have y equals x squared minus 2x minus 3. So what we're going to do is we're going to graph it by figuring out what the y-intercept is, what the x-intercept is at 1, the vertex, the x-intercept, the second intercept, the first intercept, and we're going to choose another point and figure out what it is. So off to the side here, I'm going to create an x and y table because I want to figure out what these points are. So I'm going to choose maybe 1, 2, 3, 4, 5, just basic numbers. So what I'm going to do is anywhere I see an x, I'm going to put a 1. So for my first one, y equals 1 squared minus 2 times 1 minus 3. Well, I know 1 squared is actually going to give me 1, and a negative times a positive is going to give me a negative. 2 times 1 is 2, and I'm going to bring down my minus 3. So 1 minus 2 is actually going to give me a negative 1, and if I subtract 3 more, I'm actually going to have a negative 4. So for my first point here, I'll draw in red. I'm going to have my y and x. I'm going to go left 1, and I'm going to go all the way down 1, 2, 3, 4, and put my first dot. Now I'm going to try 2. I'm going to do the same process, except now I'm going to plug in 2. So now I have y equals 2 squared minus 2 times 2 minus 3. Well, 2 squared is 4, and I know that a negative times a positive is a negative. 2 times 2 is also 4, and I'm going to bring down my 3. Remember, PEMDAS left to right, 4 minus 4 will give me 0, and if I subtract 3 from 0, I get a negative 3. So I'm going to have another dot at 2, negative 3. So I can't really tell if it's going to curve down or if it's going to actually curve up, but let's keep trying some more. So then I have y equals 3 squared minus 2 times 3 minus 3. 3 squared is 9. Negative times a positive is a negative. 3 times 2 is 6. and bring down your 3. 9 minus 6 is actually going to give me a 3 minus 3, which gives me 0. So eureka! I actually hit somewhere on our axis, on our x-axis. So there's my first point of interception. Now I'm just going to continue on with 4, doing exactly the same process. 4 squared is going to give me 16. 4 times 2 is negative 8. Or sorry, negative 2 times 4 is negative 8. 16 minus 8 is 8. 8 minus 4 is going to give me also a 4. So I have 4, 1, 2, 3, 4. And then I have 5 left here. So y equals 5 squared minus 2 squared minus 3. 2 times 2 is negative 4. 5 squared is 25. 25 minus 4 is 21. Minus 3 is going to be really big. 21, 18. So that one I can't really graph. So I definitely know my first x-intercept here, or x-intercept 1, is going to be my point right here. 3, 0. Okay? If I actually wanted to try a negative number, or what's really cool about parabolas is this. I can actually see that it's going to curve this way, right? It's going to continuously curve up. What's super cool about parabolas is they're mirrored. If I know where my axis of symmetry is, or can know where my vertex is, I can draw my actual axis of symmetry, and all I gotta do is draw the other side. So I can see that this point, my first point right here, right where this red is, my first point right here is 1 away from my axis of symmetry. So I know if I'm going to mirror it, it's going to be on the other side in the exact same spot. And then if I go up to this one right here, I know that this is 2 spaces away. So from my axis of symmetry, I'm going to stay on that same line and go over 2. And I can put the dot. And then this one I can see is 3 boxes away. So I can start my axis of symmetry and go 1, 2, and 3. That's the greatest thing about parabolas, is they're mirrored images. One side is exactly the same as the other. So now what's cool is I can figure out this second x-intercept, which is going to be right here in orange. It's going to intercept at negative 1, 0. My vertex is going to be right smack dab in the middle. So the middle point here in purple. So I know that that's 1, 1, 2, 3, 4. That is 1, negative 4. And my y-intercept is going to be where it hits my y-axis, where my parabola does. And it looks like right about here is where it hits. Oops. This is my y-intercept, which is going to be at 0 for my x, because I didn't move left or right. 1, 2, 3. Negative 3. And if I chose another point, I'm going to choose, let's do 4, 4. Why not? Okay, so that is our first one there. We will have a second video for the second one for E. Or if you feel pretty confident, try it out and see what you get.